Hi, welcome to Greg's Stone Yard. Today's video is going to be about purchasing and setting up an industrial robot in your home workshop. So what we're looking at here is a robot integrator's facility, and that right there is a fountain that I traded partially for the spindle on the robot. And again, this is just a look around the robot integrator's facility. See a bunch of used robots here. So the advantage of purchasing from a robot integrator is that it'll come with a warranty and you can see it work before you purchase it. The disadvantage is price. You'll pay a lot more from a robot integrator versus what you'd pay at an auction. The disadvantage of an auction is that there's no guarantee that the robot you purchase works, and most likely you will not be able to see it work before you purchase it, and you could just be buying someone else's problem. And what we're looking at here is the robot I purchased. It's an ABB 6640 with a 180 kilogram payload and a 2.55 meter reach. You're also going to have to think about how you're going to get it home. Most industrial robots weigh a fair amount. Mine weighed 3,000 pounds just for the robot itself, another 700 pounds for the floor plate, and 400 pounds for the control box. I also purchased a rotary table that weighed about 1,000 pounds itself, as well as a 4-foot by 12-foot cast iron fixture table that came from an old CNC machine, and that weighed in just over 5,000 pounds. So altogether quite a heavy load. And this is just the transport company backing it into my neighbor's driveway so that I can unload it. Once you get it home, you're going to have to get it off the trailer. So ideally you have a piece of heavy equipment, ideally a forklift or something with some forks. The industrial robot itself is kind of tippy, so you should have to be very careful when you're moving it. Here I am just using the backhoe and then the forklift to get all the items off the trailer. So I'll just briefly go over here the setup for the electrical for the industrial robot. So starting here is a 20 horsepower phase converter, and right now I have it running off a 100 amp breaker, but ideally it should be on a 125 amp breaker according to the manual, but so far I haven't run into any problems on a 100 amp breaker. So single phase comes into there, 3-phase comes out at 240 volts and goes into a 30 kVA transformer. And this is an isolating transformer, and you want an isolating transformer because otherwise you get a high leg out of the phase converter, and I'll go over that in depth in another video. But so this goes from 240 volt to 600 volt, both 3-phase, and again it's an isolating transformer. And then from there I come up to here, and then this panel has a couple of breakers in it. I'll open them up in a second. We'll take a look inside. Well, there's a 30 amp breaker that then comes out to this outlet, and then I use a cord to come over to this box that I've got mounted on the side of the controller box for the robot. And this has the VFD in it for the spindle, and as well as some other logic for starting and stopping the power to this control box for the robot. Okay, so with all the doors open here, we'll quickly go over it. So single phase to 3-phase digital phase converter from Phase Technologies, Phase Perfect, 20 horsepower. Power comes out of it 3-phase with a high leg, goes to this 600 volt 3-phase converter from 240 volts to 600 volts, and this is an isolating transformer, so it's a delta Y, and that gets rid of the high leg, so you don't have to worry about high voltages from ground to any leg, or to the one high leg. And then so the power comes out of that transformer into here, and then protecting the secondary side of that transformer is this 30 amp breaker. And from that 30 amp breaker, it comes down to this terminal block, and right out of that terminal block, it goes to that outlet. It also tees off and goes over to this 15 amp breaker, which I have protecting another circuit that runs another machine. It runs my CNC wire saw. But if we, so out of that 30 amp breaker, hooked up by a cord over to this box, and inside here is everything for the robot. So it comes into here, this simple on-off switch, and then down to this terminal block. From there it splits into two circuits. One is a 20 amp breaker that protects the control cabinet for the robot, and then power goes straight from this terminal block for the other circuit over to, I've got another transformer here. This is a 30 kVA 600 volt to 480 volt 3-phase transformer. And then it comes back in at 480 volts, goes through this breaker, and then over to, there's some fuses there, some 25 amp fuses, and then from the 25 amp fuses it goes down to this VFD, which powers the 11 kilowatt spindle motor. And each of those circuits are independently controlled by, I haven't labeled them yet, but this one starts and stops the power going to the robot, and this one stops and starts the power going to the spindle through these contactors here. Then there's also a 120 volt circuit, so there's 600 volts come in here, and I got 120 volts come out the other side, and that's just used for these buttons and the contactors. And as part of the VFD, on top here is a braking resistor, and that's just to use to take the excess power from the VFD when it slows down, or sorry, when the spindle slows down, the VFD takes the excess power and dumps it into this big resistor here. And we can take a look inside the control box for the robot. So none of this is my wiring. This is just how the control box comes from the factory. The only thing I had to do in here is, this is the main computer. I had to take this out. It's pretty straightforward, and replace a small one of those coin batteries inside it. But otherwise, the power comes down into here and goes out to a transformer that's in the back of here. And this one was pre-wired for 600 volts. I probably could have taken the back off and messed around with the wiring and got it to take 480 volts, but because I had another machine that used 600 volts, I just went with a this 600 volt transformer over here. Here I'm moving the 700-pound floor plate into position onto the cast iron table so that I can begin drilling and then tapping the holes to secure the robot to this table. The holes drilled and the table painted, and it's now time I can put the plate back on and bolt it down. Using the backhoe as a crane is not the ideal tool. You can see it bounce around here a lot as I try to get in position. Okay, just about to lift the robot into position using the crane on my truck. I didn't think the forklift would have enough height with the straps the way they are. So the instructions I'm actually trying to follow. You've got 4 straps and then a 5th that goes around the arm. That's just to catch it in case it tips. And so there's not supposed to be any tension on it, so I think I'm ready to give it a try. Kind of at the limit of the I'm right in between, it weighs 1,300 pounds or 1,300 kilograms, and where I need to extend it out, I'm only rated to 1,140. So anyway, we'll see how we go. I think it'll actually be in position without having to send it out all that way. Here's a time lapse of moving it into position. This makes it look like it was went pretty smoothly. It actually did, but there's a few nerve-wracking points when I had it extended all the way out, and I was trying to do very small movements, but you can see it swing there to the left, and I was just trying to move it to the right a little bit, but I kept moving the crane the wrong way. And here's what it looked like in real time, moving the robot with the crane. And finally, just using the forklift to move the rotary table into position. And now, this is the first time it moved.
It's alive! It's alive! It's alive! It's alive! It's alive! Oh, in the name of God! Now I know it feels like to be God! Now I know it feels like to be God!
So now I have the spindle installed, and that's a 11 kilowatt 15 peak spindle, and I've got a pointed tool in the tool holder, and what I'm doing is attempting to calibrate the tool, which involves bringing that pointed tool down to another point and orientating the robot in different orientations, and then it can calculate that tool center point. Actually repeated the process with a different tool that has the center point scribed on it. So just taking a close-up look at that point here on this tool. And after this was done, the robot was put in a jog mode where it can it just jogs around that point, and you can see how well it's been calibrated for that tool center point. So I think this looks pretty good, and we'll be able to move on to actually using the robot after this was done. And finally, the robot has been put to work doing something useful. Here it's flattening a slab of very hard stone. This stone was cut on the wire saw, and the wire broke while it was cutting, so it ended up with a dip in the stone, and you can hear that right here where it stops cutting. So it actually needed a lot of flattening, which was pretty much impossible by hand. So total, I think this was probably 18 hours, maybe 24 hours of runtime to flatten this. And it was done at 4,000ths of an inch at a time, or 0.1 of a millimeter depth of cut. Here's the robot putting in a good 8-hour day, just going back and forth, flattening the slab over and over again. The program was actually done in Fusion 360. It has a post-processor for ABB robots. And then I simulated to make sure it was going to work in ABB's Robot Studio. Here's a nighttime shot of it working. Thought this looked kind of cool, just the way the mist was coming off and the bubbles of the water as it sheds off the stone. Anyway, there's a lot more to actually getting this working, especially to do with the spindle, the electrical, all the software involved. Comment below if you'd like to see some more videos detailing those topics to do with the robot. And thanks for watching. Bye.